Alrighty, mathletes. Today we're going to be taking a look at how we can compose functions or do what's called function composition. But before we get to function composition, we're going to do something we don't normally do. We're going to start with a little bit of a warm-up, mostly because I want to show you guys how, in effect, you actually already know how to do this, even if you've never officially learned how to, okay? So what we're going to do is we're going to take a look at this little warm-up problem where it just says to evaluate the following if f of x is equivalent to x squared minus 3x plus 10. So basically, we got a function. It's defined as being equivalent to x squared minus 3x plus 10, and I want you to evaluate it, which what does evaluate mean? It means tell me its value at -2 and tell me its value at 5. So we're going to go and use some pretty basic simple substitution. Okay, so we are going to go and look at this function f of 2, and we're going to remember that this is really just what our input is. Okay, so we're going to say that if we're evaluating the function at f of -2, it's going to be -2 squared minus 3 times -2 plus 10. So what we really did is we said that in the function f of x, x is our input, right? So it's input squared minus 3 times input plus 10. If we're defining that input to be -2, then it's just -2 squared minus 3 times -2 and then plus 10, okay? So if we do a little bit of basic arithmetic here, we're going to remember that a negative value squared is positive, so -2 squared is 4. 3 times -2 is -6, minus a -6 becomes plus 6, and then we got plus 10. So 4 plus 6 plus 10 is just 20, okay? So by this process, what we're doing is we're using what's called substitution, okay? So what if I wanted you to go and evaluate the function at f of 5? Well, that simply means that I'm going to go and substitute the number 5 in everywhere I see the input x. So f of 5 is equivalent to 5 squared minus 3 times 5. That's one ugly 5, but hey, it still works. And then plus 10. So I just took my input value, x, which in this case is the number 5, and plugged it in. So 5 squared is 25, minus 3 times 5 is 15, and then plus 10. Doing some basic arithmetic, 25 minus 15 is 10, 10 plus 10 is 20. So I got the exact same answer, okay? That part's not really important right here. What is important is the fact that we're using basic substitution to evaluate each one of these functions. So I want you to take that, put it at the back of your mind before we start working on the next part of our lesson today, which is about composition of functions. So the composition of function f with g is expressed as, and this is where the notation gets super fun and exciting. This is read f of g of x, okay? We can also express that using just the double bracket notation where it's, again, f of g of x, okay? So a similarity that I want you to notice. When we were evaluating this function, we said f of x was the function, and we made the input -2, so it was f of -2. This is f of g of x. So what we're really saying is that if we have two functions, f and g, and we do a composition of f onto g, or g onto f, we could go the other way too if it was written a little bit differently, then the input of one function becomes really the output of a second function, okay? So to illustrate that point, I'm literally going to do another illustration. If you thought the unicorns were glorious, just wait till you see what's headed your way, okay? So we're going to go full on Animal Kingdom right now and say that we're going to have this guy right here. Oh yeah, look at that. We're going into multiple dimensions. Oh yeah, that's just amazing. Uh, uh, See, it's all the details, guys. When you're becoming an amazing artist like me, it's all about the details. All right, so we got a fish right here, okay? Big fish, got gills and everything like that. But this fish is a predator. Dun 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 dun. Look at those sharp teeth. Okay, so this we're gonna call f of x. Okay, it's a big fish. Okay, and then we're gonna have this other little fish. Okay, it's kind of smaller. It's probably a little bit more friendly. Probably doesn't have as sharp a teeth as the other guy has. But to each their own. So here we go, and we got like this little fish, and it doesn't have teeth because it's a friendly fish. It's a little guppy. So we'll call it G of X for guppy fish. Okay. Now this fish right here is going to go through and say, you know what? I'm kind of hungry. I think I would very much like to eat you, except for I gotta get myself together first before I can go and decide to have lunch. So my little illustration part might not work out as well as I was hoping, but it's cool. It's cool. We can still make it happen. So the big fish here is going to go and swim over, and it's going to eat the little fish. Dun, dun, dun. But what happens to the two fishies? Okay. Well, I started off with a big fish, and it ate a little fish. And the little fish went, and did it get stuck inside somewhere? I think it did. I think the little fish got stuck inside the belly of the big fish. So the little fish is hanging out right here. It's like, oh, you just ate me. Not cool, bro. Just hanging out in the stomach. Okay. And it's all sad. It's a sad fish. Okay. But we've got a big fish that swam by. And what did it do? It ate the little fish. So now the little fish is a part of this big fish. And that's literally what these functions are doing. One of these functions is eating the other function. And it's going in my belly. Okay. And when it goes inside of it, it becomes a part of it. Okay. The circle of life, the circle of functions. It's no wonder that there's a circle here indicating that we're doing composition between two functions, f and g. Okay, so enough National Geographic stuff. What do you say we get to the meat and potatoes, the actual arithmetic that we're dealing with here? So if we're going through and doing function compositions, okay, you're going to be given multiple functions. For this first example, we're going to say that you've been given a function f of x, and it's defined as 2x. You've been given a second function that we're calling g of x, and that is defined as being 8x minus 6. So you want to go through and you want to find what's called f of g of x. So I'm going to try and color code it for you. So everything that is involving f of x, I'll do in blue, and everything that is involving g of x, I'll do that in green. Okay, so if I go through and I write f of g of x, I'm going to do it this way. Okay, f of g of x. So what this means is that f is my big fish and g is my little fish. And f is going to go and eat function g. Okay, so what is function f? Function f is 2 times input. Okay, so I'm just going to leave a big empty open set of parentheses for this input, because you got to think of this as like it's the big fish's stomach. Now what is it going to eat? It's going to go and eat this function g. So where does this function g go? It's going to go into the stomach of the bigger fish. So 8x minus 6. Okay, now I want you to look at the fact that I've got this color coded right here. Okay, now close your eyes. Now open them. if we go and look at what we did for the warm-up where we were evaluating, did we not do the exact same thing? We just used a single number instead of another function. But the fundamental principle is the same. When we're doing function composition, we're just making the input of one function the output of another. Lots of uses for that. We'll talk about those more later. Okay, so now that I've got this composition done, I can go through and actually like do some operations to simplify it. So obviously this adjacency implies multiplication, and more specifically with the distributive property. So 2 times 8x is 16x, and 2 times negative 6 is negative 12. Ergo, f of g of x will equal 16x minus 12. Okay, please keep in mind we also could have written this as f of g of x. Okay, we can go and use either one of these ways of notating function composition interchangeably. It does not matter which way you go and do it, so long as you don't look at this one and say, oh, that looks like the letter O and f of g spells fog. Okay, it's not fog, it's f of g of x, or f composed with g of x. Okay, now the next part of our example here says that we want you to go and evaluate f of g of x 2 different ways. Okay, so there's always more than one way to skin a cat. I know I'm jumping all over fish references, cat references. We're just going bananas today. Okay, but we're going to go through and I'm going to show you how to do it 2 different ways. So just like in the warm-up, when we see evaluate, okay, it really means find me the value. Okay, so we're trying to find the value of f of g of 5. So the 2 ways that we can do that, first, you have a method where you can compose, then evaluate, or you can do what I prefer to do, which I just call inside out. Okay, so if you're going to do a composition and then evaluate, it means that first you would go through and you would find f of g of x. Okay, and then second, you could go and evaluate it. So for this particular example, we already went through and found what f of g of x was. So we've already done the composition. So we could say that f of g of x was equal to 16x minus 12. And if we wanted to evaluate that at, say, 5, we'd be doing f of g of 5. Well, then I would just be making 5 my input value, and I would get 16 times 5 minus 12. Well, 16 times 5 could be a big number. If you want to use a calculator, use a calculator. If you want to use that big, beautiful brain of yours, use that big, beautiful brain of yours. But if we do 16 times 5 and subtract it from 12, we end up with 68. Okay? So that's one way that we can evaluate a function composition. We can compose it first, then evaluate it. But here's what I prefer to do. I prefer, unless you've already done the composition, work your way inside out. So sticking with the colors, I'm going to go through and say that this g of 5 I'm going to do in blue, and then the function, or green, and then the f function I'm going to go through and do in blue, right? So first, I'm going to figure out what g of 5 is. Okay, so that's exactly like the warm-up problems. The function g was 8 times my input x minus 6. My input in this problem is 5. 8 times 5 is 40, and 40 minus 6 equals 34. So g of 5 is 34, okay? Those 2 things are interchangeable now because I've established equivalency between them. Ergo, I can go and instead of saying f of g of 5, well, I know what g of 5 is. So I can say that this is f of 34, okay? Where did that 34 come from? Okay, it came from my last evaluation of g of 5. So if I'm doing f of 34, well, that's going to be 2 times my input. What's my input in this problem? 34. What's 2 times 34? 68. Okay, so regardless of which way we went through and did it, we still came up with the same answer. Okay, so my suggestion would be, hey, if you're going to go through and do it from scratch, you could do composed and evaluate. But I would prefer, or I think it's personally easier to do inside out, but you have the option of choosing which way you think is easiest for you. All right, so let's go take a look at a few more examples of doing these different compositions. Okay, so we've still got the same functions, f of x and g of x. So I'll stick with doing f of x in blue and g of x in green. Okay, except for I'll actually make that green this time. Wouldn't that be a wonderful thing to do? So green, haha. All right, so this time we're going to go through and do g of f of x. Okay, which means that the output from the function f is going to be the input for the function g. So going along with my idea that this is really just fancy substitution, g of x, or g of its input, is equal to 8 times my input value, and then I take 6 away from that. My input value in this particular case is f of x. Well, what is f of x? It's just 2x. So if I go and do my arithmetic, I have 8 times 2x, which is 16x, and then minus 6, and that's it. So that right there is what g of f of x is. Remembering that we could have also written that as g of f of x. Okay. People always ask, whoa, can you compose a function onto itself? Yeah, absolutely, you can do that. So color coding on this one doesn't quite show you guys as much, but what I will do is I'll write 2x instead of f of x for this intercept. Okay, you can always compose a function on itself. Okay, it's pretty simple. We're just going to go f of, well, what is f of x? Well, it's 2x. So f of 2x. So that just means that I have a function f which takes an input and it multiplies it by 2. Well, what's the input for this problem? 2x. What's 2 times 2x? 4x. Easy peasy lemon squeezy. All right, so we can go through and we'll take a look at one more set. We're not going to do all 3 of these in the video. We'll probably just do the first one, and then I'm going to tweak the second one a little bit just to show you another kind of problem. But I did want to show you guys one where we end up dealing with things that have quadratics in them, because you're definitely going to be seeing those. Okay, so we'll stick with the f of x being in blue and the g of x being in green. Okay, hopefully you guys like the color coding as much as I do. So first, we have that this is equal to f of, well, what's g of x? I'm going to go ahead and write it. G of x is x plus 3. So I'm really saying in my function f of x, which takes an input and squares it, then subtracts 2 times the input, then takes one of their 15, my input is x plus 3. All right, so this is going to be f of x is input squared minus 2 times input minus 15. So let's take that input and put it in. See what I did there? I'm hilarious. All right, so we got an x plus 3, and this is also an x plus 3 because it just is what our input is. So now I can go and do some actual algebraic arithmetic. So hopefully we remember how to go and square a binomial. Okay, x times x is going to give us x squared. 3 times x, and then another x times 3 is going to give us plus 6x, and then 3 times 3 is 9. Then minus, okay, 2x, but then it's also going to be a minus 6, okay, because negative 2 times positive 3, negative 6, okay, followed up by a minus 15. Combining all of my like terms, I have x squareds here, so just one of those. I have plus 6x minus 2x, well, that's going to be plus 4x. And then I have a 9 minus 6 is going to give me a 3. And then 3 minus 15 gives me a negative 12. So f of g of x for these functions is going to generate x squared plus 4x minus 12. Okay, the last one that we're going to do here, I'm actually going to change this a bit. You ready? You ready? We're going to make this, oh, we're going to make that into an 8. Oh, that is one ugly 8, but it's an 8. So we're going to do g of f of 8. So this one we're actually going to evaluate. Okay, we're going to evaluate g of f of 8 just so we see another example. Okay, so I'm going to go through and decide to do inside out. Why am I choosing to do inside out? Well, because I think it's easier. Also, we haven't already done g of f. So the work that we did up here is not going to help us evaluate this any faster. So we're just going to go inside out. So first, I'm going to figure out what f of 8 is. Okay, so that'll look pretty much like what we did above, just without letters and only the number 8. So this is going to be 8 squared minus 2 times 8 minus 15. Okay, if you want to get a calculator for this, get a calculator for this. I'm getting a calculator for this. 8 raised to the second is 64. 64 minus 2 times 8 is 48. 48 minus 15 gives us 33. Okay, so the value of the function f when its input is 8 is 33. So what I can do here is I can evaluate g of that 33. Okay, because if f of 8 is 33, then g of f of 8 is the same thing as g of 33. Okay, so if I go and plug 33 into the function g, well, the function g is input plus 3. Well, what's my input in this case? 33. What's 33 plus 3? 36. And that is how we can go and evaluate g of f of 8. Okay, so again, to recap, today we've been talking about function composition, both pure composition and evaluating using function composition. We're always thinking of the food chain when we're doing function composition. The first function eats the second function, and the resultant function is all of them kind of combined together. Okay, it's going to be very, very similar in practice to what you already know how to do when you're evaluating functions. Okay, but for each one of these, you're just going to go and use substitution to compose or evaluate functions.